Hey everyone, we are going to take a look at lesson 6.5 today. This is on linear inequalities. So linear, if you remember, those are our functions that are a straight line. And then inequality, if you remember inequalities from earlier this year, those are going to be your greater than, less than, greater than or equal to, less than or equal to. So we're going to see an equation of a line, but the equal sign is going to be replaced with an inequality. So this one says y is less than or equal to 2x minus 3. Over here we have y is greater than x plus 1. So instead of the equal sign, we're going to have an inequality. The graphs are going to look a little bit different. You'll notice the line part of it is the same. You know, in this one we have a y-intercept of -3 and then a slope of 2. So up 2 over 1, up 2 over 1, up 2 over 1. That's forming the line. If we look at the one to the right, you can notice the difference in this line is this is what we call a dotted line. This is what we call a solid line here on the left. So solid and dotted lines are determined by the inequality. You can see that if you have the solid line, the less than or equal to, you will draw a solid line. If it's just the greater than or just the less than, it is a dotted line. You also notice that we have some shading. So the shading, what we're doing is we're shading all the possible solutions to the inequality. So any ordered pairs in this shaded region, if you were to plug them in for the x and in for the y, you would get a true statement. Any of these ordered pairs over here in this shaded region, if you plug in the x and the y, you would get a true statement. If you were to plug in an ordered pair that was not shaded, that's when you would get the false statement, and these ordered pairs over here are not solutions to the inequality. The difference between the solid line and the dotted line, if you were to pick a point from the solid line, any point on the solid line, because this line is filled and it's including all the points on the line, every point on this line is a solution. When the line is dotted, any point that's on the line is not a solution, but every single thing right above it, just a tiny bit above it, is going to be a solution to the system. Here we have our steps for graphing linear inequalities. You can pause and go ahead and write these in, but basically you're just going to solve for y if necessary, just so that you get that slope-intercept form. You're going to graph using the y-intercept first, plot your y-intercept, and then do your slope. So at this point you're just going to have your points on the graph, and then you have to determine, are you going to have a solid or a dotted line? Again, that will be based off of the inequality, and then you're either going to shade above or shade below the line, and that is also based off of the inequality. So how do you know if you should have a solid or dotted line and if you will be shading above or below? Here's just a little reference we can put in our notes. Anytime that you have a greater than, you are going to shade above. If it's greater than, dotted line. If it's a greater than or equal to, solid line. Now let's look at our less than options. Anytime it's a less than, you're always shading below, but what will the line look like? Well, if it's just your less than, dotted line. If it's your less than or equal to, so a nice little thing to remember, if it has the line, the or equal to line, it is a solid line when we graph it. Okay, so let's get into some examples having to do with our linear inequalities. First example, tell whether the ordered pair, so each example has an ordered pair, is a solution of the inequality. So in our ordered pair, we have an x and we have a y. And all we're going to do is we're going to plug those in to our inequality and see if we have a true or a false statement. So first we are going to plug in the y, so we're going to say 3 is less than, and our x value is 7 minus 1. We're just going to do the math on each side of the inequality, so 3 is less than, 7 minus 1 is 6, and then is 3 less than 6, is that true? That is true. So is the ordered pair 7, 3 a solution to the inequality? Yes, it's the solution. If we were to graph this, this ordered pair would be in the shaded region of the graph. Alright, so let's just take a look at another quick example. We have the ordered pair 4, 5, so here's our x, here's our y, and we're going to plug it into our inequality here. So we're going to replace the y with a 5 is greater than 3 times, we're going to substitute in the 4 for our x, add 2. So again, just do the math on either side that needs to be done. So 5 is greater than 12 plus 2. 12 plus 2 is 14. So is 5 greater than 14? No, it's not. So is our ordered pair a solution to the inequality? No. Now, if you were to graph it, would this ordered pair be in the shaded region of the graph? No, it would be on the other side of the line that doesn't have all of the shading. Right, so our first linear inequality we're going to graph is y is greater than 2x minus 4. So we are already solved for y, so it's slope-intercept form. So it's helpful just to identify our slope is the number with the x, so 2. I'm going to go ahead and say 2 over 1. And our y-intercept is that negative 4. We're going to write it as an ordered pair, 0, negative 4. So when we graph this, we're going to start with a y-intercept at negative 4. So make sure you do put that on the y-axis. And then from there, we're going to go up 2 over 1. You do want to go ahead and fill in your whole graph with these ordered pairs. And then it's really tempting just to draw the line right away because that's what we're used to doing from our linear functions. But we have a couple decisions to make. We have to decide, are we going to have a solid or dotted line, and are we going to shade above or below the line? So it all comes down to this inequality. So greater than, if you notice it's not greater than or equal to, it's just greater than. So that means we are going to draw a solid line through our points. So let's go ahead and draw that. And of course that's not what it is at all. Did you guys catch my mistake? Let me see if I can undo that. All right, so when you have your greater than, it's not greater than or equal to, so this is a dotted line. Are you guys using a pencil? I hope so. Or you're not even listening to the video, but you should be. All right, so there is our dotted line like that. And then are we going to shade above or below the line? So greater than, y is greater than the line, is going to shade above. So sometimes the steeper that your line gets, it can be trickier to figure out what's above and below the line. So the easiest little trick I give students is if you go to the y-intercept at negative 4 and either draw an arrow straight up or straight down. So because we're going to shade above the line, I am going to draw an arrow straight up. So that's the side that we're going to shade on. And then all that we're going to do is shade everything above that line. Just like that. So these two examples, we are being asked to write the inequality ourselves based off of the graph that we're given. So you can see that we have to figure out what the slope is in the y-intercept, and from that we can just go straight to our slope-intercept form. So y-intercept, maybe I'll fill that in first. Y-intercept I can see is right here. We're going through 1 on the y-axis, so we are going to write 0, 1 for our y-intercept. For the slope, go left to right from one point to the next. Do your rise first. So I'm going to just go from that y-intercept because that point is already highlighted for us. We're going to go up 1, 2, 3. So our rise is 3. We're going to run 1, 2, 3. Our run is 3, so our slope is 3 over 3, but we're always going to reduce slope if we can, so really we just have a slope of 1. So our inequality, normally if we were to write the equation, we would say y equals, and so I'm going to kind of leave that space blank because we haven't talked about what it's going to be yet. And it's going to be 1x, or just x plus 1. So the question is, what's going to go right here? Not an equal sign, because we can see that we have some shading in our graph, so it's an inequality. So is the shading above the line or below the line? So again, just go to your y-intercept, go straight up or straight down, which side has the shading, and because it's straight up, that means we are shading above. So shading above gives us two options. It's either going to be greater than or equal to. So to determine which one of those, look at your line. Is it a solid or dotted line? We can see it's dotted, so that means it's just the greater than. So we're going to fill that in. Y is greater than 1x or x plus 1. Alright, so last example here. Y-intercept, I guess that's what we started with last time. If you look at this graph, we have this point on the left highlighted, this point on the right highlighted. They didn't actually highlight the y-intercept for us, but we can follow along with the line and see where it crosses the y-axis, which is going to be right there at -3. So our y-intercept is 0, -3. Now the slope, we will go from the points that were highlighted because those will just be the easiest to work with. Starting with the 1 on the left, you do your rise first, so 1, 2, 3, 4. We rose 4. And positive 4. Had we gone down, I would have said a negative. And then we run 1, 2. So our slope is 4 over 2, rise over run, which will reduce to just a 2. So our inequality, y, I'm going to skip the inequality part for a second, just because I want to talk about it. But our slope 2x, and then our y-intercept -3. So we're just going straight into that slope-intercept form. Now, to determine the inequality, look where your shading is. Here's our y-intercept. Did we shade straight above or straight below? So I can see straight below, so that's the side of the line that got shaded. So that's your less than. So it's either going to be a less than or equal to. So do we have a solid or a dotted line? And you can tell the line is filled in, it's solid, so we're going to pick less than or equal to.